Let's say you just dug a hole all the way through the Earth from somewhere in the northern hemisphere, straight down, through the core, out the other side. You're standing at the edge, looking down, and the answer already feels obvious. Jump in, fall through, pop out on the other side. Like a cartoon, simple, logical, completely intuitive, and completely wrong. Physics has prepared 3 surprises for you, each one worse than the last. Let's start before you even jump. You're standing at the edge of your perfect hole, a straight tunnel drilled exactly through the center of the Earth. Everything seems fair. But here's the question. Is the Earth itself standing still? No, the Earth is rotating. Right now, as you're watching this, you're moving with the surface of the planet at around 400 meters per second. That's if you're somewhere in the mid-latitudes. At the equator, it's nearly 465 meters per second, faster than sound. You don't feel it because everything around you is moving at the same speed. But the tunnel goes straight down. Relative to the center of the Earth, it's fixed in one direction. The moment you jump, the problem begins. You carry your horizontal rotational velocity with you. The tunnel goes vertically downward. Within seconds, you're no longer falling through the center. You're drifting sideways. You slam into the wall of the tunnel within the first few kilometers. The experiment is over before it started. Physicists call this the Coriolis force. You can call it whatever you want. The point is, you're in the wall. But we're not stopping there. That would be too easy. Let's assume, just assume, that the engineers of the future solved the problem. The tunnel rotates with the Earth. Coriolis is compensated. You fall perfectly through the center. Great. Now, you have a new problem, and it is significantly hotter. Literally. The Earth's crust is roughly 30 to 70 kilometers thick, depending on where you're digging. Below it, the mantle. Temperatures there start around 500 degrees Celsius and climb with every kilometer down. By the lower mantle, you're looking at around 4,000 degrees. And the core? The outer liquid core sits between 4,000 and 5,000 degrees. The inner solid core? About 6,000 degrees Celsius. That's comparable to the temperature of the surface of the sun. Not the core of the sun, the surface of the sun. No known material survives those conditions long enough for the tunnel to stay a tunnel. But we're playing fair again. Let's say the tunnel is magically insulated, protected, holding together, so you keep falling. And this is where physics prepares its best trick. If you made it this far, subscribe, because what comes next is the best part. You're flying through the center of the Earth. Your speed has been building the entire way down. At the very center, it reaches approximately 7.9 kilometers per second. That's nearly 8,000 meters per second. First cosmic velocity, the same speed at which satellites stay in orbit, except you're going vertical through liquid iron. You pass through the center. What happens next? Gravity starts slowing you down. The same force that accelerated you downward now pulls you back symmetrically. You decelerate. By the time you reach the other end of the tunnel, on the opposite side of the Earth, your speed drops to exactly 0. You surface just to the edge of the opening and stop. Not a centimeter higher. Physics doesn't let you fly out into the air. You don't pop out like a champagne cork. You hang there for a fraction of a second and fall back in. Back toward the center, back up the other side, again and again. This is called harmonic oscillation, a pendulum. You are a pendulum inside the Earth. In a frictionless ideal tunnel, you swing forever from one side of the planet to the other every 84 minutes, never flying out, never arriving anywhere, trapped in the largest pendulum in the history of human imagination. And here's the thing. You thought you knew the answer. You were sure. Intuition said jump, fall through, land on the other side. But physics has spent thousands of years building tools that are more precise than any instinct. Planetary rotation, core temperature, gravitational mechanics, each one alone already destroys your plan. Together, they turn the simplest question in the world into 3 layers of completely unexpected answers. That's not a reason to be frustrated. That's a reason to respect physics. Because a world where science is smarter than our intuition is a world where there's always something new to discover. If you want to keep discovering, hit like. The next video starts with a question that sounds even simpler and turns out to be even stranger.